The power property is going to be a little bit different than the previous two. The power property is going to be about coefficients. A coefficient is a number in front of an expression, so it's multiplication, but the power property is the idea that coefficients, spelling is hard, become powers, but on the inside. So a coefficient, in other words, a multiplication on the outside, becomes a power on the inside. This property does go both ways. There is a corollary with exponents. Let's say you have 2 to the 3rd power, and then we raise all of that to the 4th power. That's a power on the outside. Well, that becomes 2 to the 3 times 4. That becomes multiplication inside. So there is that corollary with exponents. It's just not quite as nice as with the product and quotient properties. So with exponents, powers outside became multiplication inside. With the power property on logarithms, coefficients, which is multiplication outside, becomes a power on the inside. What that's going to look like is a formula. Note, in this really tiny font, there's that little n up there. That's going to become a coefficient, a number on the outside. Still going to have a log base b of m on the inside. So coefficients become powers, powers become coefficients. It still goes both ways. So let's look at 13 there. That 5 on the outside, 5 times log base 4 of 2, that coefficient is going to become a power. Let's see, let the base be blue. What did I do? Red for the inside. It's beautiful. That 5 is going to become an exponent of the 2. We can reduce that because 2 to the 5th power. We have log base 4 of 2. 2 to the 5th power is 32. Jumping over to 14. Note that now in 14 I actually have an x, a variable in there. No big deal. That 7 is still a coefficient. So we want that coefficient to become a power because we're trying to condense. So we have an x to the 7th power. Can't do anything to simplify that one, so that's just done. Last but not least, jumping over to 15. 15, note we have a 1/3 on the outside, so that's going to become an exponent on the inside. So we have a log. Remember, if there's no base, that's a log base 10. So we have log base 10 of 8 to the 1/3 power. Now keep in mind, we did see an example like this before where we raised a number to a 1/3 power. That 1/3 power is the same thing as a cube root. So 8 to the 1/3 power, well, 8 to the 1/3 is just 2. So that simplifies to a log base 10 of 2. So that's condensing, bringing that coefficient to the inside, turning it into a power. 16 through 18, we're going to do the opposite. We're going to expand. So taking a look at 16, that 7, which is an exponent, is going to come out front. That's going to be a log base 2 of 8. We can actually clean that one up a bit because log base 2 of 8, well, 2 cubed is 8, so log base 2 of 8 is just 3. And 7 times 3 is 21. So sometimes you can go a bit further. 16 is an example where we can. So that's nice. Taking a look at 17. 17, quite fun. Note that now my exponent has a variable in it, that x minus 1. So that's going to become a coefficient. Of course, I already have a coefficient, so there will be a little bit of distributive property here. 17 is kind of tricky. So I still have that 3, it's still there. That x minus 1 comes out front. And then I have a log base 10, because there's no number there, log base 10 of 4. So to clean this up a bit, we could do that distributive property. 3x minus 3 times log base 10 of 4. kind of ugly. Note though, what's nice about this problem is I did used to have an x in the exponent there. Now it's just a coefficient. So if I wanted to solve for x, let's say this was equal to 0 or equal to 1, something like that, I could just divide, add 3, and then divide by 3. We're not ready to solve equations yet, but stuff like 17 is eventually what we'll be doing algebraically. Last but not least, number 18. I did show an example similar to this in a previous video. Keep in mind, this is a bit above the AB level, but that square root of w, we can rewrite that square root as w to the 1/2 power. Again, we don't play with those fractional exponents too much, but the same property does apply. That 1/2 comes out front. We're left with log base 7 of w. Again, that's not something that'll show up on a test or, God forbid, on the final. But it is nice to be able to see that these same properties work even when we're playing around with radicals. 15 was another example of that 8 to the 1/3 power becoming a 2. Keep in mind you will have your calculator on you for these tests and quizzes, but you won't need to worry about these fractional exponents. Occasionally they'll slip in the Math Excel. So raise your hand if you have a question, let me know what you need. That's it for this section, getting these properties down. There is a quiz at this point that you would be able to take. I do have a spiral review ready if you want to try some review problems. If you want to hold off on the quiz, you could definitely move to the next section. And just for funsies, if you are still listening to this video, send me an email, and in that email include lyrics to your favorite school-appropriate song. You'll earn a bonus point. It'll be fun. See you soon.